So what we're going to do next, I'm going to demo this. I'm going to minimize my elements, and I'm going to bring up my 9.1 full version. So once you get good at Simplest, what you will find is that the number of things, analyses, the number of corner cases that you can do to explore the robustness of your design is pretty amazing. And the more painful it is for your first prototype to not work, the more you're going to want to use Simplest to explore these corner cases and really try to flush out design errors before you commit to first hardware. So when you're in that mode where either the thing you're making is so small, like an IC, or this little tiny power supply, anytime it's painful for the first prototype to not work, you're going to end up, once you get good at Simplest, wanting to really exercise it to flush out as many design errors as you possibly can before you commit to first hardware. Once you do that, you realize, oh my goodness, I am running a ton of simulations. I have to run hundreds, not just a few, but I have to run hundreds of simulations in order to really do that. Just like you do when you think about when you get your first hardware back and you go in the lab, you don't just run 5 or 6 or 10 sims and it's all good to go. No, you're in there for days, weeks, sometimes characterizing, making sure everything's working just right. So it's the amount of sims that you end up wanting to run are pretty amazing. So what we have developed and is available as an add-on to the full version is a thing we call our design verification module. And I'm just going to make this a little bit bigger. And I'm just going to do a real quick example here. And then after this, we'll take a quick break, and Christoph, you'll be up next, and Jens after that. Okay, so design verification module is a way of automating a whole suite of simulation checkout runs. Okay, so I'm just going to show one example. We have a number of built-in test plans. So this happens to be a sync buck. So I'll use the sync buck test plan. And it allows us to do a whole bunch of different tests. So I'm just going to do a couple things. So at nominal, I'll do 100% load. We'll go to minimum input voltage, 100% load for the Bode plot. You can also do conducted susceptibility, input impedance, output impedance, all set up. Well, tons of different transient runs. We'll do a step load, light load to 100%, step line, startup, short circuit. So I'll do so we can just do a dead short, or you can do a short circuit and then let the system recover. So we'll do that. And then steady state tests, or if you're doing efficiency and stuff like that. So we've checked those tests, and now we'll launch those. And so what DVM does is it'll take this test plan, figure out, okay, it'll configure the schematic so we have the correct input and output conditions. If you decide in the test plan you need to modify some component values, it does that, launches the simulation, then does the measurements on the waveforms, the circuit waveforms. And then it will actually compare those measurements. If you have specs for those measurements, it'll compare the measurements to the specifications. And you have different specs for each test. Okay. And then once you've run all the simulations, you've gathered up all the waveforms, you've measured the waveforms, you've compared the waveforms, against the specifications, it'll automatically generate for you a test report. So these are the results. Okay. So you can see we ran 4 tests, 1 passed, 2 failed, and 1 did a warning. So, if I click and go here, there's a whole raft of measurements that we made. This was a Bode plot. So We always measure efficiency, gain crossover frequency, gain margins, and that sort of thing. And you can see we passed our maximum and output voltage, gain margin spec, and crossover and phase margin spec. We failed here. So this is minimum input voltage. And here we're looking at the gain in green. And it is at minus something. It's low. The gain, even at low frequencies is very low. And so the question is, what's going on there? And we weren't able to measure gain margin and phase margin. And the problem was that, so the gain is actually below zero. So you can't do a phase margin, can't do a gain margin measurement. And again, this is because the system's it's just on the edge of current limit. So the voltage loop isn't controlling the system, but it's still in spec. It's, the voltage is still within its spec, but the current limit is what's controlling the duty cycle. Therefore, the gain and phase margin, it's warning. It says, I can't make this measurement. You need to check this out. Then we have, and we'll just look at one of these, say like the short circuit and recover. A lot of things failed here. So here we start out in steady state. Output voltage looks to be 1.5 volts. Huge current spike when we short out the output caps. You can see that this, we shut down and then try to start up. Oh, still got the short there, turn off. So we're going there. Finally, the short is removed, but then we have a massive overshoot. And so we've failed the overshoot spec. Okay. So these are the kind of things that, DVM can do for you. So you could be running, hundreds of tests, and, it will do the analysis and say, hey, you really need to take a look at these results, make sure that everything's working the way that you want it. Or if it's failing, then you got something you need to fix. Okay, so any questions at this point, Matt? Or I think we'll take a 5-minute break and give Christoph a chance to get set up.
No, I believe we are good.
Okay, excellent. So we will take we'll take a 5-minute break. So that means 22 minutes after the hour, we'll start up again, because we have some really cool, really good stuff that we want to share with you. So Christoph is going to share some of these templates that he's put together and some really cool modeling and measurement techniques. And then right after that, Jens is going to do just a 5-minute thing on show you what multi-level modeling can be in the hands of a seasoned expert. So we'll be back, we'll say right now at 24 minutes after the hour.